up to 5 years before major symptoms appear. The AI analyzes subtle patterns in speech, typing speed, and even eye movement data collected from a patient's smartphone. While this is a monumental breakthrough for preventative medicine, it also opens up a complex ethical debate around data privacy, pre-diagnosis anxiety, and the potential for insurance discrimination. The FDA has stipulated strict data handling protocols, but the conversation is just beginning. Our fourth story, from November 3rd, comes from the world of open-source AI. As covered by The Verge, the French AI company Mistral, in collaboration with Germany's Aleph Alpha, has released a new open-source model called Europa 1. This 1 trillion parameter model is unique because it's multilingual by design, trained natively on over 50 languages, rather than being English-centric and translated. Early benchmarks show it outperforming many leading models on non-English reasoning and cultural nuance tasks. This is a significant challenge to the dominance of US-based AI labs and a huge win for a more globally inclusive and accessible AI ecosystem. Developers are already buzzing about the possibilities. On November 4th, we saw a major policy development. The BBC reported that the European Union has officially passed the AI Workforce and Education Act. This legislation mandates that all member states must integrate foundational AI literacy and ethics courses into their national high school curriculums by 2027. It also allocates a €10 billion fund for retraining programs aimed at workers in industries most likely to be disrupted by automation, such as logistics, administration, and manufacturing. This proactive, large-scale approach to managing the social transition of the AI revolution is being watched closely by governments around the world as a potential blueprint for the future of work. Now, for something a little different. On November 5th, a story in Nature magazine detailed a breakthrough in scientific discovery. Researchers at Caltech have used a specialized AI, which they've named Curiosity, to discover a new, highly efficient catalyst for splitting water into hydrogen and oxygen. This is a critical step for green hydrogen production. The AI sifted through millions of potential molecular combinations, a task that would have taken humans centuries, and identified a novel compound in just 3 weeks. This is a prime example of AI not just optimizing existing processes, but accelerating the pace of fundamental scientific discovery, potentially fast-tracking our transition to cleaner energy. Midweek, on November 5th, Bloomberg reported that the global supply chain is getting a major AI upgrade. Maersk, the shipping giant, announced it has completed the rollout of its Quantum Root AI platform. This system uses real-time satellite data, weather patterns, port congestion, and even geopolitical risk analysis to dynamically reroute its entire fleet of container ships for maximum efficiency. In its first 3 months of full operation, it has already reduced fuel consumption by 15% and cut shipping delays by an average of 20%. This level of logistical intelligence is unprecedented and is expected to have a ripple effect, lowering costs and increasing the resilience of global trade. Our eighth story, from November 6th, dives into the world of robotics. Wired magazine featured a story on Boston Dynamics' latest creation, the Archivist robot. Unlike their more athletic models, the Archivist is designed for delicate tasks. It uses advanced computer vision and haptic feedback sensors in its fingertips to handle and digitize fragile ancient documents and artifacts. It was demonstrated at the Vatican Secret Archives, where it was able to scan brittle manuscripts that were previously too delicate for human hands or traditional scanners. This fusion of robotics and AI is opening up new frontiers for preserving our shared cultural heritage. Then, on November 7th, we saw a significant shift in the consumer tech space. According to a press release picked up by major tech outlets, Samsung has announced that its next generation of smartphones, the Galaxy S26 series, will feature an on-device AI chip powerful enough to run a 15 billion parameter language model locally. This means no internet connection is needed for advanced conversational AI, real-time translation, and sophisticated photo editing. This Edge AI approach offers huge benefits for privacy and speed, as your personal data doesn't need to be sent to the cloud. It marks a major step towards making powerful AI a truly personal and private utility. And for our final story, also from November 7th, the New York Times published an in-depth piece on the AI composer phenomenon. An AI model named Euterpe's Muse has generated a full neoclassical symphony that was performed by the London Philharmonic Orchestra. The piece has received critical acclaim for its emotional depth and structural complexity, with some critics admitting they couldn't distinguish it from a human-composed masterpiece. This has ignited a fierce debate in the art world. Can AI truly be creative? Is this art, or just a sophisticated imitation? It challenges our very definitions of creativity and authorship, and it's a conversation that will undoubtedly continue for years to come. And that's a wrap for this week's AI News Summary. From global safety standards and creative revolutions to scientific breakthroughs and the future of work, it's clear we are living in a transformative era. The pace of innovation is just astounding. What story caught your attention the most? Let me know your thoughts in the comments below. Thank you so much for tuning in. If you found this summary helpful and want to stay updated on all things AI, please give this video a thumbs up, subscribe to the channel, and hit that notification bell so you don't miss our next update. It really helps the channel grow. Thanks again for watching, and I'll see you in the next one.
Hello everyone, and welcome back to the channel. Today, we're retaking a deep dive into a topic that's both fascinating and a little bit mind-bending: the story of Manus AI. But here's the twist. We're going to explore its development as if we're looking back from October 2025. This is a speculative journey, a thought experiment based on current trends and expert predictions. So grab your thinking caps and let's explore the future that might be. To understand where Manus AI could be in October 2025, we first have to look at its hypothetical origins. Picture this. In late 2023, the AI landscape was dominated by large language models excelling at text and image generation. However, a quiet revolution was brewing. A consortium of researchers from leading universities and independent labs, let's call them the Ether Initiative, published a groundbreaking paper. Their focus wasn't on making AI bigger, but smarter and more integrated. They proposed a new architecture, codenamed Manus, Latin for hand, symbolizing its goal to give AI the ability to interact with and understand the physical world in a much more direct way. Their core idea was embodied cognition. Instead of just processing text from the internet, the Manus project aimed to build an AI that learned from multisensory input, sight, sound, and, most importantly, virtual touch and proprioception. They developed incredibly sophisticated simulations, digital twins of real-world environments, where the AI could manipulate objects, learn physics, and understand cause and effect. The early Manus prototypes weren't great conversationalists. Ask them about poetry, and they'd be lost. But ask them how to assemble a flat-pack chair from a diagram, and they could generate a step-by-step robotic instruction set with 99% accuracy. This was a radical departure from the norm. Throughout 2024, the Manus project hit several key milestones. In March, they demonstrated an AI that could watch a cooking show and then guide a robotic arm to replicate the recipe, adjusting for slight variations in ingredient size and placement. This showcased its adaptability. By summer 2024, they had integrated advanced voice and sentiment analysis. Now, Manus could not only understand the instruction "pass me the wrench," but it could also infer from the user's tone of voice whether the request was urgent, casual, or frustrated, and adjust its response speed accordingly. This emotional and contextual awareness was a game changer. The real breakthrough, however, came late in 2024. The Ether initiative announced they had successfully federated the Manus learning process. Instead of one massive central AI, thousands of smaller, specialized Manus nodes were deployed in various industries, from logistics warehouses to virtual surgical suites. Each node learned from its specific environment, and these learnings, stripped of any proprietary or private data, were shared back to the core model. This swarm intelligence approach allowed Manus to learn exponentially faster, an improvement in grasping delicate objects learned by a node in a Japanese electronics factory could be applied to a node assisting in a German laboratory overnight. By early 2025, the first commercial applications of Manus AI began to emerge, not as a single product, but as an operating system for robotics and smart devices. A company specializing in elder care introduced companion robots powered by Manus. These weren't just glorified smart speakers, they could help with daily tasks. Notice if a routine was broken, provide physical assistance, and even detect a fall and call for help. The key was their understanding of the physical space and the context of human action. They didn't just hear "I've fallen," they could see it, understand its implications, and act. In the manufacturing sector, Manus AI created what experts called hyperefficient assembly lines. Instead of robots programmed for one repetitive task, Manus-powered systems could be reconfigured for new products in hours, not weeks. They could perform quality control with superhuman precision, detecting microscopic flaws and even predicting mechanical failures before they happened. This led to a significant boost in productivity and a reduction in waste. With sources like the Future of Manufacturing journal estimating efficiency gains of up to 40% in early adopter factories. This wasn't about replacing human workers, but augmenting them, freeing up people to handle complex problems and creative design, while the AI managed the dangerous, repetitive, and precise physical tasks. Of course, this rapid development wasn't without its challenges. By mid-2025, debates around ethics and governance were front and center. How do you ensure the safety of an AI that controls physical machinery? What happens if a learning node picks up a bad habit? The Ether initiative, now a larger foundation, worked with international standards organizations to develop a robotic code of conduct. This included principles like the reversibility principle, ensuring any action taken by a mouse-powered robot could be safely and immediately halted or reversed by a human operator, and the sanitized learning protocol, a rigorous process to filter and anonymize all shared data to prevent the spread of errors or malicious inputs. Now, as we stand here in our hypothetical October of 2025, Manus AI is not a sentient being from a sci-fi movie. It is a powerful, specialized tool, a nervous system for the Internet of Things. Its primary interface isn't a chatbot, but a seamless interaction with the world around us. Urban planners are using Manus simulations to model traffic flow and emergency response with unprecedented accuracy. Scientists are using it to automate complex lab experiments, accelerating research in medicine and material science. It's the invisible intelligence that helps a prosthetic hand feel more natural, guides a delivery drone through a complex urban environment, and ensures the smart factory runs smoothly. The story of Manus AI, from a research paper in 2023 to a foundational technology in 2025, is a testament to the power of a different approach. It shows a shift from purely digital intelligence to an embodied intelligence, one that understands and interacts with our physical world. It's a future where AI is not just a brain in a box, but a helpful hand, working alongside us to build a safer, more efficient, and more responsive world. The next chapter, leading towards 2030, will surely focus on making this technology more accessible, more secure, and even more integrated into the fabric of our daily lives. Thank you so much for joining me on this speculative journey into the future of AI. What do you think the next big breakthrough will be? Let me know your thoughts in the comments below. If you enjoyed this video, don't forget to hit that like button and subscribe for more deep dives into the technology that's shaping our world. Stay curious, and I'll see you in the next one. Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that's been setting the tech world on fire: Google SVO3. If you've been following the progress of generative AI, you know that text video has been the next great frontier. We've seen incredible leaps, but what Google is promising with VO3 and what we've seen so far feels like a paradigm shift. We're going to break down everything we know about VO3 as of October 2025, look at its journey, and peek into its future. So, what exactly is VO3? Put simply, it's Google DeepMind's latest and most powerful text-to-video generation model. It builds on the foundations laid by its predecessors, Lumiere and the original Veo, but the jump in quality and capability is staggering. According to a landmark paper published on Arxiv in August 2025, which you can find linked in the description, Veo 3 utilizes a novel space-time diffusion transformer architecture. This sounds complex, but the core idea is to understand video not just as a sequence of images, but as a holistic block of space and time. This allows it to generate motion that is incredibly smooth, consistent, and physically plausible. Let's rewind a bit. The journey here didn't start overnight. Remember back in early 2024 when Google first announced Veo? It was impressive, capable of generating minute-long clips in 1080p. It was a direct competitor to models like Sora, and the race was on. At the time, Veo was praised for its understanding of cinematic language. It could create drone shots, time-lapses, and dolly zooms just from a text prompt. Then came Veo 2, which was previewed at Google I/O 2025. The big update there was consistency. Characters and objects remained coherent across multiple shots, a huge challenge in earlier models. Veo 2 also introduced rudimentary in-video editing capabilities, allowing users to tweak generated clips with further text prompts. This brings us to Veo 3. The leap from 2 to 3 isn't just about better pixels. It's about a deeper understanding of our world. The new space-time diffusion transformer allows it to generate videos up to 5 minutes in length at a crisp 4K resolution. But the resolution is just the beginning. The real magic is in the details. In a demo reel released by DeepMind, which we're showing clips of now, you can see examples that are almost indistinguishable from reality. Prompts like a photorealistic shot of a red panda solving a Rubik's Cube in a sun-drenched library result in a video where the fur texture, the lighting, and the intricate finger movements are all perfect. One of the key innovations highlighted in that ArXiv paper is something called latent physics. Injection during the training process, the model wasn't just fed videos, it was also trained on simulated physics data. This allows Veo 3 to have an intuitive grasp of concepts like gravity, momentum, and fluid dynamics. When you ask it to generate a slow-motion clip of a water balloon bursting, it doesn't just create a colorful splash. It accurately simulates the tension of the rubber, the surface tension of the water, and the way individual droplets arc through the air. This is a game changer for realism. Another massive improvement is in character and narrative consistency. With Veo 3, you can define a character, say Detective Miles Corbin, a grizzled gumshoe in a trench coat, and then generate a whole series of scenes with him. You can prompt Detective Corbin interrogating a witness under a single dim lamp, followed by Detective Corbin in a high-speed car chase through rain-slicked city streets, and the model will maintain his appearance, clothing, and even subtle mannerisms across both clips. This opens the door for independent filmmakers and creators to storyboard and even produce entire short films using AI. So, how does it stack up against the competition? While other models have also improved dramatically, Veo 3's main advantage seems to be its integration with the broader Google ecosystem. According to a blog post from the Google AI team, also linked below, there are plans to integrate Veo 3 directly into YouTube. Imagine a Create with Veo button right in YouTube Studio, allowing you to generate custom B-roll, background animations, or even entire videos just by typing a description. This could democratize video creation on a scale we've never seen before. The training data for VO3 has also been a topic of much discussion. Google has been very clear that it was trained on a massive, licensed dataset of high-quality stock video from providers like Shutterstock and Storyblocks, as well as a vast library of publicly available and permissively licensed content from YouTube. This addresses many of the copyright concerns that plagued early image and video generators. By using a properly licensed dataset,